Good morning and a very, very warm welcome to our satellite event called From Lab to Production Line. Today's event takes place as an official satellite event as part of the International Conference on Research Infrastructures. This conference takes place in Brno in the Czech Republic during this week. We as Fraunhofer Research Institution Battery Cell Production are very grateful to get the opportunity to host this event and share our thoughts about research and development in the area of battery cell production. I'm very pleased to walk you through today's event. My name is Thomas Paulsen and I'm leading the business development group at the Fraunhofer Research Institution Battery Cell Production. As I already mentioned, we will talk today about battery cell production. Battery cells are the smallest piece of a battery power source. Such power sources are used in various applications like power tools, electric cars, mobile devices, energy storage systems, and so on. For example, in an electric car, there are several hundred or thousands of small battery cells interconnected to drive the car. Due to finite natural resources like oil and gas, the increasing demand of mobile power sources, and topics like the Green Deal, accelerating the growth of such global industry for battery cell production is an important endeavor. How the global industry for battery cell production can be supported within the next years by players out of the academia, research and development will be answered during our event today. Therefore, we prepared three sessions for the event. Today, and the first session is about the current status of battery and battery production research. Here we have a slight focus on especially the European landscape. The second session shows three different possible approaches and networks to overcome the hurdles. Between 12:45 and 2 p.m. we make a break to refresh ourselves, and within the last session starting at 2 p.m. we will talk about the most important cross-sectional topics for battery cell production, namely digitalization and sustainability. But before we start our first presentation, I would like to thank you, dear participants, for your interest and participation to our satellite event. Furthermore, we would like to encourage you to participate to the event in an active way and use the possibility to ask questions to our speakers. Now I would like to hand over to Jens Tübke for the first presentation. Just 2 or 3 sentences about Jens Tübke. He's spokesman of the Fraunhofer Alliance Battery and he's the institutional director of Fraunhofer Research Institution for Battery Cell Production. We're very happy to have you here and to share your thoughts on the current situation in battery R&D.
Yeah, good morning, everybody. Thomas, thank you very much for a nice introduction. I'm having the honor to be the first this morning to start with the first session and with the first talk. And I try to take you a little bit on the current situation on battery research, how it's organized in Europe, in other countries over the world, and what are the main topics and what's the key ideas about battery R&D within this month and maybe in the upcoming years. So as a first teaser, the European Commission and the community has wrote down some key facts about batteries and battery research, and maybe it's somehow an idea why we increase our efforts in battery research and battery production research since a while, and we will do it more in the future. It's clear that if batteries are true enablers, if it's possible to make them more sustainable, safe, high-performing, and also affordable, the first key fact. Another one is that batteries allow smart mobility. They can supply clean and affordable energy, and they can mobilize our industry for a clean and circular economy. And another fact is that batteries are helping to better carbon dioxide emissions in terms of transport, power industry, systems. This is the motivation to do more in battery research, to do more in energy storage research. If we have a look on some worldwide targets and timelines, and we see that all big economies and most of the large industrial countries and areas have somehow their own targets and their own strategy and idea behind that. But what is common and what we can see here, that there is a strategic approach for research, that we are now in a situation that this research and the results have to help the industry, that it's really in need of commercialization of the innovations, that there is a clear focus on automotive industry, but also on stationary energy storage, for example. Every country, we will see it later, have somehow their own roadmaps, how they expect, what materials they expect, what production technologies they expect. And when we put it a little bit together later, we will see that there are similar approaches, of course, and that the countries itself, there are different ways how this is organized, how it's financed, and how it's the closing work together with the industry. And we did a bit more focus on the European situation. And here we see in small overview, I just took one of the many pictures which were drawn over the last months to describe this situation in Europe. And what we see is that we have a strong European battery alliance, where researchers all over Europe, but also from industry are organized, are involved in the activities. That there is a European technology and also innovation platform organized with a holistic strategy on R&D. That there are short but also medium-term technology roadmaps are written, and these activities they are coordinated all over the countries with this European approach, and that there are different programs and possibilities to have close interaction between all of the stakeholders in Europe, but also the possibilities to write down programs, to prepare projects, large European projects, to work on these different topics. Horizon Europe is one of the biggest activities, and the idea is really to organize, to set some partnerships and organize these activities. Additionally to this, we have the IPCIs for first industrial deployments, and this is also in coordination with national and also private funded R&D activities all over Europe. This summer, everything was a little bit stretched together with the idea to combine the European Technology Innovation Platform, Batteries Europe, and But4U as a European partnership, and they organized the 4 working groups from new and energy emerging battery technologies up to stationary applications and integration, where many people, researchers, and also people from industry are working closely together in those work groups, and can share ideas. They can also set some programs and write in these work groups roadmaps and those things. So this is the 3 tasks which are executed by these working groups here on the right side. These are technology reviews. We see roadmaps and some strategic actions up to scope topics prioritization, and also which is the most important thing in the end for our researchers here, it's a Horizon Europe calls drafting, and this will then be allow more well-defined and roadmap-driven research organized with the European Commission. Yeah, in Germany, we have also a strong and well organized battery research activities, mainly funded by two ministries, Ministry of Education and Research and Ministry of Economic Affairs and Climate Actions. There are also funding from other ministries with some side actions, but these are the both which are giving most money, of course, and they define the battery research activities. So these are our funders, and the other side we have large variety of scientific research organizations in Germany, which are doing those battery research, and starting with the Fraunhofer Society. We will hear more about these activities with other talks, but also from Helmholtz Association with Leibniz and even with the German Research Foundation and Max Planck with a more basic research. These are involved in this electrochemical energy storage. Which is organized between a more industrial-driven applied research, like Fraunhofer is doing, up to a pure basic research, like Max Planck is. So the idea behind and why, especially the ministries are giving a lot of money since many years into battery and electrochemistry research, is that they have the idea and the dream to set up an entire battery value chain, not only in research, but also in transfer into industrial activities, and to also accelerate this transfer. This allows new markets. This can also open new markets in a wide range of battery applications. So many of industrial activities in Europe, but also in Germany, are focusing on battery research or on this value chain, but also focusing on application in need for energy storage, mobile and stationary. So it's really very important point to have a strong battery research in Europe, but also battery research and battery industry to open up all of the possibilities. We need the digitalization topic, which we also hear about more in another session. And we look back, let's say 15 years roundabout, maybe 20, then electrochemistry was not in the main focus at German, but partially also on European universities. And with this fundings and with this really focused program topics on electrochemistry and then battery and also on fuel cell research, this was changing over the time. And now we have a situation that we have a strong community which can research on future battery generations, but also on production technology and all of the topics which are necessary to have a good research over the complete value chain. We have to think about the next generation of scientists. So industry is demanding a lot of our people, from technicians up to our PhDs. So we have to think more about education and training for academic, but also for non-academic, not only for our research activities, but also for setting up the necessary industry in a scale-up. And especially the BMBF, German Ministry of Education and Research, has set up an innovation pipeline to have one side a mission-driven approach, and on the other side a non-mission driven approach, and of course we foster international networking. And this is shown on this slide here, the so-called roof concept battery research with the two approaches. One is a mission-oriented approach, top-down, and bottom-up, the non-mission-oriented approach. And the idea is really to go over this value chain from the basic research up to technology ready for industry in innovations to bring them into industry, but also over the complete value chain from materials up to production topics, recycling, sustainability, and all of the things to close really the circular economy to bring back materials into usage for batteries. We have also international driven programs, which are international European activities, for example, with Japan, Taiwan, Israel, for example. And actually, we are working in a program Battery 2020. We are organized in mostly 7 competence clusters, which I will show you later, and the Fraunhofer Research Institution for Battery Cell Production in Münster, which is set it up in a moment. Münster is also a strong part of this, and you will hear about later from Florentin. Yeah, this is a so-called umbrella concept or roof concept of the BMBF, and this shows the cluster research approach with the different modules here. Our ministry calls it factory module, but in fact it's more a cluster of R&D, which where many different projects are organized with this topics. For example, with some material related topics which are organized here in this cluster. We have Excel BATMAT is a competence cluster for battery materials, and another one is a competence cluster for solid state batteries, FESTBAT. So we have the different clusters organized in these modules, and you see it's going from material to cell processes up to battery cell production with the cross-section topics, analytic and quality assurance, for example, and recycling, green battery competence, and cluster of battery utilization concepts. And again, our research factory, battery cell research production, is also part of this. You see, it's a green arrow here in the factory module 3 with battery cell production. Yeah, and as announced, I'm a speaker, spokesman of the Battery Alliance of Fraunhofer. Maybe you know Fraunhofer as an applied research organization where more than 70 institutes are organized within the Fraunhofer world. And 24 of these Fraunhofer institutes are doing some research on the battery topic. So we have not this one battery research institute, but we have many different institutes which are also involved with their work into some battery related topics. And this is organized somehow again over the value chain from materials to recycling LCA. And we address different markets, which you see in the different gray colors here. So it's well spread around Germany. Okay, this is just one teaser because you will see more details later on. This is so to say for us the end of this value chain where we have the production, but it's not true end, not so where it goes back then after usage and recycling into the circular economy with our materials for our battery cells. Yeah, this is a view on some roadmaps. Together as different roadmaps from different countries, China, US, Japan, for example, here. It's a picture where you can see Japan Rising 2 plans. You can see European set plan targets, Chinese targets with red stars here. This shows that this is still very ambitious up to 2030. And what we also see that most of the roadmaps are focusing on lithium metal usage and also focusing on solid state batteries in the end to increase performance, to get higher energy densities, and to fulfill needs, especially with ambitious needs for automotive industry. So a little bit more in detail. These are the European targets where some generations are defined. Now we are working with generation 3, the so-called advanced lithium-ion technology. Generation 4 will then solid-state lithium-ion batteries, and later than 2035, the so-called post-lithium-ion technology is expected as the generation 5. And the targets for 2030, in this case, we are in the range of more than 500 watt-hour per kilogram, 800 plus watt-hour per liter, and this is what expected for this technology, especially for solid-state ion technology. Yeah, looking on lithium-ion batteries in common, I don't want to tell you how it's working. Maybe you are quite involved into this technology. Mostly we focus more on the electrode material itself, but what is very important and where more of the R&D focus is laid on is our production technology, and on the way to a solid-state technology, also the question how to set up a cell design and with what type of electrolytes we combine our electrode materials. Current concepts are classic coated or non-coated PE/PP separator, polyethylene, polypropylene, in combination with liquid organic electrolytes and salt. Somehow we combine it with ceramic coatings or particles. But the question or the problem is that we have still the problem of melting of a separator, certain temperature, some gas formation possible, mechanical damage is possible, and in the end, if you overheat, you can even burn your electrolyte, and this is the complete cell. So the idea is really to change this, and when we have a look on the aging behavior over time, the material which is performed different with a different state of ages, which means that also the parameters of the cell is changing over application of 10 to 15 years, for example. And we see also a strong need not only on material research to increase performance and lifetime, but also to have a close look on aging behavior and to understand what happens. Mostly we see that even after 10 or 15 years we can work with a cell. Maybe we have to change application, but we have to understand what happens. We have to be able to describe aging behavior, the safety of the cell even after 10 years. We have many effects. I don't want to go in detail here. You can have a look on that. Quite old picture from 2014. So these are well-known processes in terms of we know what happens principally, but we have to better understand in detail. But we have also be able to simulate and to model those behavior to really bring it together with some description of aging over time, for example. Yeah, the idea is then to change this, to change the mechanism, how the cell is working, and one of the approaches is a solid-state approach, where we have also different ion transport in the end. We see bottom line with the ceramic electrolytes, we see the transport of ions into the solid-state material, into within the ceramics. You have somehow a single ion conductor, and this is quite different to a solvatized lithium cation in a liquid electrolyte, where we have a transport of solvated anions and cations. This is the idea behind, and there are many different materials on the market. So today we talk about oxides, phosphates, sulfides, different glasses. We talk about polymer materials, polymer geels with some plasticizer, or even combination of both materials, polymer electrolytes containing some ceramic materials. What we see here is quite clear when we compare it with the performance of the ionic liquid electrolyte, and we see that we have to improve the ionic conductivity, or that we have to work at higher temperatures with those materials. And also we have to learn about many different interface behaviors between those materials and the electrodes. We have to think about and to work on protection layers between the different materials we use here. So it's a large R&D field again. And a wise thing in a moment is to pick up some materials which are working, and to slightly start with the next step, think about production technology which is necessary, and really try to think materials, cell design and production technology from one hand to be successful within the next 10 years, when we expect in 2030 some solid state based cells approaching the market. Okay, our colleagues from Fraunhofer ICRI are doing a lot of road mapping work. So this is our solid state battery roadmap. From this year, we see not only the different KPIs from the European Commission, which I told you before, 2030, 500 watt-hour per kilogram, 800 plus watt-hour per liter, but there's also described some solid state battery cell concepts, and also some KPIs which might be possible with the different technologies, means with the different types of ceramic materials, polymer approaches. So we see that there are some sets of material which can be expected to enter the market in 2030. What we need is the combination of this material and design of cell approaches with the production technology. But this we will also hear a little bit later, a bit more in detail. Okay. I think this is my last slide, and this sums up a little bit the development strategies. This is here done from the perspective of automotive engineering, but it's true for most of the technologies or most of applications where we need battery energy storage in market. And this is a combination of a low cost and high energy density cell, which is able for fast charging, long lifetimes, environmental friendly and safe. Environmental friendly can also be set with a circular economy. And what are the main approaches? Moment is, for example, high nickel rich cathodes with some particle doping or coating. The addition of silicon to anode materials, or even silicon-based anodes. Also very important, inactive materials, to use advanced inactive materials to speed up electron transfer, for example, to have ultra-thin separators, use different electrolyte formulations for different SEI approaches, for example, to influence the aging behavior and to control the aging behavior. But thinking into some module and battery development, also to combine this with the cell design, this cell-to-pack approach, for example, using of lightweight and safety materials or safe materials. In the end, as I said before, solid state technology is a solid state with hybrid methods with the different approaches for this solid electrolytes. Okay, thank you very much. I'm at the end of my talk, quite good in time. I would like to say thank you if you have questions. I'm with you here. Thank you for listening.
Yeah, thank you, Jens. Quite interesting speech. Are there any questions from the audience? So during your talk, there was one question whether the event is recorded and is presented or is published afterwards. We try to record the event, and if there's no, let's say, arguments against the publishing, like legal or technical ones, we will publish the event and the presentations on our YouTube channel. afterwards. Okay, any questions? Okay, then I have one question to Jens. Quite interesting to see all the activities on the European level, BEPA, batteries, 2020, and all these ideas. Do you see let's say, topical area where the European R&D landscape is especially strong?
I would like to try to answer the question where we have to be strong. We have to be strong in thinking about our raw materials and about resources, and to keep resources in Europe. And this is also a very large field in R&D, which is set up in a moment and which will be more important for the next years and also for the next programs which are upcoming. How to upscale material production, how to upscale recycling technology, and how to keep a circular economy, especially for the materials within Europe. Yeah.
Okay, thank you. And there's another question. I just read it out of the chat. Do you have a view on the inspection technologies for battery cell production and how this improve yield?
How it's good. Yeah, we have to increase yield. I mean, everybody which is working with production technology knows about the yield, and there's a wide possibility to increase this. I think that yeah, the cell production and how to do it changed over the last let's say decade or half decade. So much more digitalization, much more simulation on the processes is approaching this field, and this helps a lot to understand more the production process, to go away from the try and error approach 20 years ago, to say, and we can. This helps a lot to understand and to increase the yield. And another point is that we have a lot of changes in production technology steps itself, with the laser cutting, with dry coating, and many different approaches, even with different setups of ideas of cell designs, for example, which we have to do with the idea to bring costs down and use less material and so on, but also to work on yield.
Okay, thank you very much. Thank you, Jens, for your presentation.